Hello students, welcome back to my channel. Can you imagine a world where prices possess a mystical power, a force that can shape the decisions of both consumers and producers? Welcome to the realm of price elasticity of demand. It's a captivating concept that reveals that there's a very delicate balance between prices and consumer behavior. It unveils the secret as to how a small change in price could send ripples of change throughout the marketplace. Well, that's our topic for today. We'll be discussing degrees of price elasticity of demand. So without wasting any time further, let's dive in. The first concept here is unitary elastic demand. This is a scenario where a percentage change in the quantity demanded of a particular commodity is equal to the percentage change in the price. For those who don't know what price elasticity of demand is, please check out my previous video. You would get to know the concept and the formula for calculating price elasticity of demand. Now, if we look at the schedule here, we see that we have price in terms of dollars and demand in terms of units, and we can observe that the price has gone up from $10 to $11, and consequently the law of demand operates. So the demand for the commodity has gone down from 100 units to 90 units. Now numerically, if we see the change here, there's a change of about 10 units when it comes to the quantity demanded, and just $1 when it comes to the change in price. To calculate the percentage change, all we have to do is take the changed amount over the original amount multiplied by 100. You would get the percentage change in that segment. So this is the percentage change in quantity demanded, which is 10%, and for price it is minus 10%. Again, in the previous video I have explained that we do not consider the minus sign for the sake of simplicity. By substituting the values of percentage change in quantity demanded and percentage change of price in the formula for calculating PED, we get the value which is equivalent to 1. Now what does this indicate? It indicates that whenever the price is changing by a certain percentage, the quantity demanded would also change by that percentage. So that's what we mean by unitary elastic demand. Now when we plot the diagram here, on the y-axis we measure price in terms of dollars, on the x-axis we have quantity demanded in terms of units, and we can see that the change in price is almost equal to the change in quantity demanded. The demand curve, the slope of demand curve in this particular scenario is called as a rectangular hyperbola. This indicates that below this demand curve, whichever rectangle is getting formed, all these rectangles would have the same total area. If we know a little bit of maths, the area of a rectangle is calculated as breadth into length. So when we calculate this, the area of this rectangle would be exactly equal to this one. This is what we mean by a rectangular hyperbola. Another way to put it would be any point on this rectangular hyperbola demand curve would indicate that a change in price or a percentage change in price is exactly equal to the percentage change in quantity demanded. So whether it is this point, which is point A, or if there is a point B, or if we get another point C, at each of these points the price elasticity of demand or PED would be equal to 1. Now what commodities have this kind of a demand pattern? You would see commodities like basic clothing and footwear. I'm not talking about branded clothes, I'm talking about just a basic clothing that you would get from a general store in your local area, or generic medicines which are considered to be a cheaper alternative for branded medicines. So commodities like these would have a unit elastic demand. The next is elastic demand. We also call it as relatively elastic demand. In many curriculums, it is also referred to as highly elastic demand. Now, in this case, what happens is the percentage change in quantity demanded is greater than the percentage change in price. That means the consumers for the commodities that have elastic demand are greatly sensitive to changes in price. That indicates that when a price change occurs, the effect of that change on demand would be tremendous, would be larger than what the price would have. So when we see in this particular schedule, the price has gone down from $10 to $8, which is a change of $2, and corresponding to this, since the price has gone down, the quantity demanded has gone up from 100 units to 150 units, which is a change of 50 units. So numerical change is to $2 in price and 50 units in quantity demanded. When we convert that into percentage change, we observe that the price change has occurred by 20% and the demand has changed by 50%. Substituting these values in the formula, which is percentage change in quantity demanded over percentage change in price, we get a value of 2.5, which is greater than 1, which is the value of the coefficient for elasticity of demand under elastic demand. It's greater than 1. When a scenario like this gets plotted on a graph, this is the kind of situation you would observe. What happens here is, again, y-axis has price measured in terms of dollars, x-axis in terms of quantity demanded in units. So, a smaller change in price from P to P1 has caused a greater change in quantity demanded from Q to Q1, and this arrow has been plotted in the wrong direction. Let me just quickly correct that. So this is the direction in which the demand has changed. So since the price has gone down from P to P1, we can observe very evidently on this graph that it's a smaller change as compared to the change that has occurred in the quantity demanded from Q to Q1. As a result, my DD, which is the demand curve, it's a flatter curve. The kind of commodities you would see here that have an elastic demand, or for the commodities which consumers are pretty much sensitive to price changes, could be your luxurious items such as a car, a mobile phone, or maybe your air travel or a 5-star vacation, your branded clothes. They all fall in this category. This category here is inelastic demand. Just like elastic demand, in many curriculums this is also referred to as highly inelastic demand or relatively inelastic demand. In this scenario, percentage change in quantity demanded is less than the percentage change in price. When we take a look at the schedule here, the price has gone down from $10 to $7 with a $3 change, and the commodities demanded have gone up from 100 units to 110 units with a 10 units change. When we convert it in terms of percentages, so the percentage change in price is 30% and the percentage change in quantity demanded is 10%. Substituting these values in the equation for calculating PED, we get a value which is equivalent to 0.33. This value is certainly less than 1, hence the value of the coefficient of elasticity is less than 1. When we take a look at this graph here, on the y-axis we have price in terms of dollars, on the x-axis we have quantity demanded in terms of units. It is evident very much clearly in this graph that the change in price from P to P1 is much greater than the change in quantity demanded from Q to Q1. As a result, the demand curve DD is a steeper curve. The kind of commodities that fall under inelastic demand category, or under the category where consumers are not much sensitive to price, or probably they cannot afford to be sensitive to prices or changes in prices, are edibles or food items like milk, bread, your regular grocery items. So the demand would rise, but it would not rise in a very great quantities. That's what we mean by inelastic demand. So the next is perfectly elastic demand. What we can observe here is it's a situation which is theoretical. We generally do not see it in our regular lives. What happens here is there's an infinite demand at a given price or at a particular price. So at price P, we can see my demand curve here is a horizontal curve parallel to X axis, indicating the demand which is infinite. And if there is a slightest rise in the price, or the price changes or increases even slightly, the consumers would stop buying this commodity altogether. So demand would become zero. Now this is a scenario we generally do not see or observe in real life. Hence this scenario is considered as a theoretical situation. The last degree of elasticity of demand is perfectly inelastic demand. What happens here is there is absolutely no change in the quantity demanded, whatever be the change in price. So if we see in this graph, if the price falls down from P to P1, there is no change, the demand remains at Q. If the price rises from P to P2, again there is no change in quantity demanded, giving us a vertical demand curve. Hence the value of coefficient is equal to 0. My demand curve is a vertical line parallel to the y-axis, and again this concept is considered theoretical, but there are few commodities that would still fall under this category. One such commodity is surgical procedures or medical treatments that consumers may need. So even if this procedure is costing him a fortune, consumers will go ahead and avail that procedure because it's their life is at stake, right? So in those cases, technically the demand does not change. So these are the 5 degrees of price elasticity of demand. I'll meet you next in another video. Until then, take care. Bye bye.